Dear students, welcome to my classroom. In previous class, we solved some problems related to curved surface areas of combinations of solids. In this class, we are going to discuss about the volume of combination of solids. Students, in this concept, we are going to find out the volume of combinations of two or more solid objects. Okay, so here I have a cylinder and a cone. So after joining these two, we get a new solid object like this. Okay. Now the volume of this object is volume of cylinder plus volume of cone. Okay. So the volume of the solid so formed is equal to sum of the volumes of the objects we have taken while forming this solid. Okay. And similarly, one more example. Here I have a cone and a cylinder and an hemisphere. So after attaching these three objects together, so we get this shape. And volume of this solid object is equal to volume of cone plus volume of cylinder plus volume of hemisphere. Okay. So that is the volume of the solid object by joining two or more solid objects is equal to sum of the volumes of all solids that we have taken. Here we have to remember one thing, that while finding the curved surface areas of combinations of solids, we may not able to see some faces of that the objects we have taken. But coming to the volumes of the solids, the total volume is equal to sum of the volumes of all objects we have taken. That is, while finding the surface areas, we are deducing some areas of some surfaces that we may not able to see. Okay, but the volume of the solid objects of combinations is equal to sum of the volumes of all objects that we have taken. We have to consider this thing. Okay, so let us solve some problems in exercise 10.3. The first one is, an iron pillar consists of a cylindrical portion of 2.8 meters height and 20 centimeters in diameter and a cone of 42 centimeters height surmounting it. Find the weight of the pillar if 1 centimeter cube of iron weighs 7.5 grams. So here an iron pillar is the combination of a cylinder and a cone. Okay, so like this. So in this picture, a cone is surmounted by a cylinder is surmounted by cone, and it is given that uh, the height of cylindrical portion is 2.8 meters and diameter is 20 centimeter. So as the two objects attached with the same base, the diameter of cone is also 42 centimeters. Okay, diameter of the cone as well as diameter of cylinder is 42 centimeters. So Let us find the total volume of this object. So first take cylinder. So for cylinder, the diameter is given that 20 centimeter, so that its radius is equal to half of the diameter, that is 10 centimeter, and the height of the cylindrical portion is given that 2.8 meter. But as all the measurements are given in centimeter, so change it into centimeters. That is 2.8 meters is equal to 280 centimeters. That by multiplying 100, we get the value in centimeters. Okay, the height is 280 centimeters. Now the volume of cylinder is pi r square h. So substitute pi is equal to 22 by 7 and r is 10 and h is equal to 280. So then we get the volume as 88,000 centimeter cube. So the volume of cylinder is 88,000 cubic centimeters. Now consider about the cone. And for the cone, the diameter is given that 20 centimeter. So the radius is equal to 10 centimeter. And the height of cone is given that 42 centimeter. Okay. So height is 42 centimeter. Now the volume of cone is equal to 1 by 3 pi r square h. So by substituting pi is equal to 22 by 7 and r is 10 and h is equal to 42, we get the volume as 4,400 cubic centimeter. So the volume of cone is 4,400 cubic centimeter. Now the volume of this iron pillar, volume of this iron pillar is the sum of the volumes of cylinder and cone. So volume of cylinder plus volume of cone, and we have got that volume of cylinder is 88,000 centimeter cube and volume of cone is 4,400 centimeter cube. So now the volume of iron pillar is 92,400 centimeter cube. But we have to find the weight of this pillar. It is given that 1 centimeter cube, that volume of 1 cubic centimeter of iron weighs 7.5 grams. So the weight of total pillar is 7.5 into 92,400 grams. Okay, as the weight of 1 centimeter cube iron is 7.5 grams, then the weight of 92,400 centimeter cube is 7.5 into 92,400. So that is we get 6,93,000 grams. As we convert it into kilograms, by dividing 1000 this value, we get 693 kilograms. So the weight of iron pillar is 693 kilograms. Okay, students. So this is the solution of this problem. So let us take next one. A toy is made in the form of hemisphere surmounted by a right cone whose circular base is joined with the plane surface of the hemisphere. The radius of the base of the cone is 7 centimeter and its volume is 3 by 2 of the hemisphere. Calculate the height of the cone and the surface area of the toy corrected to 2 places of decimal. So here the toy is in the form of a cone surmounted by hemisphere. Okay. Now it is given that the radius of both hemisphere and cone is 7 centimeter. The radius of the base of the cone is 7 centimeter. So that the radius of the hemisphere is also 7 centimeter as they attach it together. Now here radius of cone is 7 centimeter. Let h be the height of cone. So here the height of cone is not given. So first we have to calculate the height of the cone. Let h be the height of the cone like this. Now it is given that volume of cone is 3 by 2 of volume of the hemisphere. Okay, volume of cone is 3 by 2 of the volume of hemisphere. So as we have volume of cone is 1 by 3 pi r square h and volume of hemisphere is 2 by 3 pi r cube. So we get 1 by 3 pi r square h is equal to 3 by 2 into 2 by 3 pi r cube. So we can cancel 2 in both numerator and denominator as well as 3. And from this, we can write h is equal to 3 pi r cube by pi r square. By transposing the 3 and pi r square to right side, we get h is equal to 3 pi r cube by pi r square. And you can divide pi in both numerator and denominator. And also we can cancel 2 r's in numerator and denominator. And then we left with 3r in numerator. So that h is equal to 3r. But it's given that radius is 7 centimeter. So that height is equal to 3 into 7, which is equal to 21 centimeter. So the height of the cone is 21 centimeter. Now we have to find the surface area of this toy. So this toy is consists of both cone and hemisphere. So to find the curved surface area of this conical part, we have to find its slant height because the curved surface area of cone is equal to pi rl. So the slant height of the cone is L is equal to under root r square plus h square. So by substituting r is equal to 7 and h is equal to 21. So L is equal to root 49 plus 441, that is under root 490. So its nearest value is equal to 22.135. By finding square root of 490, we get its nearest value 22.135. So the slant height of the cone is 22.135. Now the surface area of the toy is equal to curved surface area of cone plus curved surface area of hemisphere. So here we cannot see the base of both cone and hemisphere. So just we have to take their curved surface areas, which we can see. Okay. So now the surface area of toy is curved surface area of cone plus curved surface area of hemisphere. And we know that curved surface area of cone is pi rl and curved surface of hemisphere is 2 by 3 pi r cube. So sorry, pi rl plus 2 pi r square. Curved surface area is 2 pi r square. So now taking pi r common, pi r into L plus 2r. Now substitute pi is equal to 22 by 7, r is equal to 7 and L is equal to 22.135. Now we get 22 by 7 into 7 into 22.135 plus 2 into radius 7. So by cancelling 7 and by simplifying, we get 22 into 7 to the 14 plus 22.135, that is 36.135, which is equal to 794.17. So the surface area given toy is 794.17 centimeter square. Okay, students. Now let's take the third one. Find the volume of the largest right circular cone that can be cut out of a cube whose edge is 7 centimeter. Okay. So we have to find the volume of the volume of the cone which can be carved out from a cube whose edge is 7 centimeter. So here I have a cube and this is the shape of cube, which can the largest shape of this is the shape of largest cone which can be cut out from this cube. Okay, so given that the edge of cube is 7 centimeter, so take it as A, and then the diameter of the largest cone that can be cut out from this cube, so this diameter is equal to the edge of cube. So the diameter of the largest cone that can be deduced from this cube is equal to edge of cube. Okay, so which is equal to 7 centimeter. So the radius of this cone is 7 by 2 centimeters. And the height of this cone is equal to height of the cube. The height of the cube is nothing but the side of cube. So the height of the cone is h is equal to edge of cube, which is equal to 7 centimeter. Now we have got the measurements of this cube, this cone, that is radius of this cone is 7 by 2 centimeters and the height of this cone is 7 centimeter. Now the volume of this cone is equal to 1 by 3 pi r square h. So substitute r is equal to 7 by 2 and h is equal to 7. So from this we get 1 by 3 into 22 by 7 into 7 by 2 into 7 by 2 into 7. So after simplifying this value, we get 89.83. So the volume of cone that can be cut out from a cube of edge 7 centimeter is 89.83 centimeter cube. Okay. So here write centimeter cube. So take another one. A cylindrical tub of radius 5 centimeter and length 9 centimeter is full of water. A solid in the form of right circular cone mounted on a hemisphere is immersed into the tub. The radius of the hemisphere is 3.5 centimeter and height of cone outside the hemisphere is 5 centimeter. Find the volume of water left in the tub. Okay, students. So here we have a cylindrical tub of radius 5 centimeter and length 9.8 centimeter, which is filled with water, and a solid in the form of right circular cone mounted on a hemisphere is fell down into the tub. Then we know that some of water in the tub flows out and some water remains in the tub. Now we have to find the volume of water left in the tub. Here the measurements of the object which has immersed into the water is given. So the object is in the shape of right circular cone mounted by hemisphere, and the radius of the hemisphere is 3.5 centimeter and the height of cone is 5 centimeter. Okay, students. So this is the cylindrical tub, and this is the object which has immersed in the tub. So after immersing, some water flows out, and now we have to find the volume of water left in the tub. Okay, so it is given that radius of cylinder is capital R, as there are two radii which are different. So we have taken here the radius as capital R. So radius of cylinder is capital R is equal to 5 centimeter, which is given in problem. And also height of the cylinder is given that 9.8 centimeters. So here we are taking the height of cylinder as capital H, which is equal to 9.8 centimeter. Now the volume of the cylinder is pi r square H. So pi is 22/7, r is 5 and H is 9.8. So that is 770 cubic centimeter. That is the volume of water in this cylindrical tub is 770 centimeter cube. So the volume of water is equal to volume of cylinder. So volume of water in cylindrical tub is 770 centimeter cube. Now radius of the hemisphere is 3.5 centimeter and the height of cone is 5 centimeter. Now the volume of object immersed in water, that is this toy, is the volume of cone plus volume of hemisphere. So the volume of cone is 1/3 pi r square H and the volume of hemisphere is 2/3 pi r cube. So take pi r square by 3 common. So we get 1/3 into pi r square into H plus 2r. And by substituting pi is equal to 22/7, r is equal to 3.5 and H is equal to 5. We get 1/3 into 22/7 into 3.5 into 3.5 into 5 plus 2r is equal to 7. Okay. So after simplification, we get this value as 154. So the volume of object immersed in water is 154 cubic centimeter. Now, after immersion of this solid into tub, the volume of water left in the tub is equal to volume of tub minus volume of solid, because the volume of water flows out is equal to volume of the object immersed into the tub. So that the volume of water left in the tub is equal to volume of water, that is volume of tub minus volume of solid. So volume of tub is, which is in the shape of cylinder, is equal to pi r square H. So already we had find the value as 770 and the volume of solid is 154. So 770 minus 154, which is equal to 616 cubic centimeter. So the volume of water left in the tub is equal to 616 cubic centimeter. Okay, students, that's all for today. So in next class, let's complete the remaining problems in this exercise. Until then, see you. Bye.